All right. A solid cube of side 0.15 is an average density of 210. Calculate the weight of the tube. Okay, remember that weight is the force of gravity, right? So it's m times g. M is just density times volume, right? So it's rho vg. You should be good to go, right? The cube is placed in gasoline of a density of blah, blah, blah. Calculate the proportion that is above the surface, right? Okay. Definitely you want to hack this one, right? So you've got this thing there, right? And this thing is, most of it will be above, right? Okay, so it's like, okay. Remember that the x submerged, you'll have to do a little subtracting here, is to the length of the cube, right? So x is to 0.15 as the density of the object is to the density of the fluid, right? So you can figure out, 720. There we go. So you figure out that x, right? But of course, you can also just look at this ratio right here. This is the amount that's going to be submerged. So the amount that's above is going to be 1 minus that ratio. Okay. Yeah, it's more than half, I'll just say. Okay. All right, let's look at the next page here. Water flows through a constricted pipe, vertical tube. So here, this is clever here, right? You've got 3 marks, right? The first mark is talk about, because this area here is smaller, presumably smaller, right? Okay. It doesn't get wider, okay? Because it's smaller, talk about what happens to V, right? Talk about the velocity. The velocity is either more or less at B, so talk about that, right? Okay. Talk about the Bernoulli principle. The Bernoulli principle states that when the water is traveling here, the fluid water is traveling faster, the pressure will be lower, right? Faster is lower pressure. There's lower pressure, right? Right, and then our third mark is you want to relate that the pressure to the height that the fluid rises, right? This is high pressure would tend to push the fluid higher, and a low pressure would push it not as far. Okay, those are your 3 marks.